A pleasant day, everyone. Today we're going to be discussing about something we plantitas and plantitas know very much. The coconut coir from coconut husk, which is often promoted as an environmentally friendly alternative to peat moss in gardening. As a soil amendment, it helps retain moisture and aerate the soil. Although aside from that, cocopeat is used in a lot of ways, like rugs, ropes, brushes, and stuffing. So before we start, I am Eduardo Di Matocto Jr., a mechanical engineering student at Technological University of the Philippines, Manila. And in behalf of my co-proponents, I present to you our work entitled Design and Fabrication of Cocopeat Machine. To start, we have here the project assembly. The design consists of a separator drum, including a hopper, counter blades, and two row blades with a helical configuration separated by 180 degrees. It also features a sterilizing drum composed of a heating system and a winnowing screen with 8 mm rings connected to the shop by 6 studs with a 25 mm screen mesh. The cocopeat production machine was designed to produce sterilized cocopeat that can be readily used for agricultural purposes. So we have here the isometric view of the machine, and these are the parts. First, we have the drum shell. These upper and lower shells are joined together by two 1-inch cylinder hinge welded onto a 9 mm plate and are pinned together using a 75 mm long by 12 mm mild steel rod. The lower shell is bolted onto the frame using four doublers made from 6 mm mild steel plate. So this is where the coconut husk is entering. And we also have here a GIF of what's the actual process. Next, we have the drum blades. Blades of the drum are arranged in pairs, with each pairs offset by 45 degrees. 10 pairs of blades with 50 mm even spacing are welded onto the pipe. The 11th pair of blades are welded parallel to the length of the pipe as a paddle to show fibers out of the drum. Then the sterilizing drum. This is where the heating process is happening. The sterilizing drum station of the machine composed of two components, mainly the heating drum and the heating system. The heating drum will also be placed onto the frame where it will rest above the stove fueled by LPG. The heating drum will also come with an exit valve to easily dispose of used water to make change of the water easier. And then frames. The frame supports the shell, the bladed drum, the engine, and the heating drum. The main support shells and the bladed drum are fabricated from 2 by 2 by 3 centimeter square tube. The supports for the engine and heating drum are fabricated from 1.5-inch by 1.5-inch by 3.3 mm angle bar at a 45-degree angle using the same angle bars. So this is the decorator parts inside the machine. Also, we have here the winnower. The winnower component acts as a final separator of the core dust and the core fibers. It utilizes a rotating motion for better efficiency as opposed to the screen sheave, which was initially proposed. A frame support and a catch basin were incorporated with the winnower component. So this is the actual view. And then of course we have the winnower frame, which is made by 1.5 by 1.5 by 3 mm thick angle bars. The angle bars were welded to build a 1085 by 700 by 700 mm frame for the winnower. So this is the winnower frame. Also, we have the winnower hopper. The winnower is made from 1.5 mm thick black iron sheets. The black iron sheets were cut to form the 330 by 330 mm inlet and a 200 by 100 mm outlet for the hopper of the winnower, and the fabricated hopper was bolted to the winnower frame. And next, we have the catch basin. This is where the product is released after the winnower processing.